Good afternoon, good morning, everyone, and welcome back. I hope you all had a refreshing break. While we are waiting for people to join, I will go over some summary of this morning sessions. This morning, we had a great start to our joint AGU AMS Climate and Health Showcase. We kicked off with engaging, welcoming remarks from Susan Annenberg and Hunter Jones, followed by an insightful keynote from Dr. Young Liu, who talked about wildfire smoke and health impact. Our first session featured cutting-edge research on the updates on tempo, air pollution, heat stress, infectious disease, drought health impacts, and innovative tools for health applications. It was a morning filled with thought-provoking presentations and discussions. As we move into the afternoon, we have an equally compelling lineup. We will begin with a crucial conversation on environmental justice, led by Dr. Sesunika Ivy. Environmental justice is not just a buzzword, it's a pivotal aspect of addressing climate change and health inequities. As we delve into these discussions, we aim to highlight the disproportionate impacts of environmental hazards on marginalized communities and explore sustainable solutions to mitigate these challenges. Following the environmental justice talk, we have 2 more sessions planned, each moderated by experts in the field. These sessions will continue to explore the intersection of climate and health, showcasing research on a variety of topics. We're also looking forward to our second keynote of the day from Dr. Chris Ebi, a renowned expert on the intricate interplay between climate change and public health. She will be shedding light on the vital research gaps and needs within the climate and health field. Her talk will navigate through the complexities of mitigation and adaptation, offering insights into the policies that can shape a healthier, more resilient future. The session proposals for AGU and AMS is open, and we will share the links in the chat with you. Please consider submitting proposals for the sessions to ensure we have a good diversity of the topics for both AGU and AMS upcoming events. So we're still waiting on some people to join. And you can unmute yourself and ask questions in the Q&A session part, or you can leave your questions in the chat. We will monitor the chat and ask your questions. Just double checking if our speakers are here. Okay, I'll go ahead and hand it over to Eufoma and Greg, who are moderating our environmental justice talk. And with that, the floor is yours. Maybe you can start with the introduction till Dr. Ivy joins.
Sounds good. Thanks so much. Hi, my name is Ufwoma. I'm joined here by Dr. Gregory Jenkins, and we'll be moderating the conversation today. And our speaker today is Dr. Sesunika Ivy. I'll read her bio. Dr. Sesunika Ivy is an assistant professor in the Civil and Environmental Engineering Department at the University of California, Berkeley, and the principal investigator of the Air Quality Modeling and Exposure Lab. She earned her PhD in environmental engineering from Georgia Institute of Technology. She was a postdoctoral researcher in the Department of Physics at the University of Nevada, Reno, and was also a visiting scientist at NOAA's Geophysical Fluid Dynamics Laboratory. She's an emerging leader in the areas of regional air quality modeling and its applications and community-scale air pollution exposure assessment. Her research interests lie at the nexus of air pollution science and engineering and environmental justice, and she works in partnership with community organizations across California to prevent over-industrialization of already overburdened neighborhoods. I was honored and excited to see Dr. Ivy's talk at AGU and really inspired by it. And so I'm happy to get to hear from her again today, and I'll hand the floor off to you.
Hi, can everyone hear me?
Yep, you're good.
Great. Thank you so much, especially to Afoma for bringing me here and to be a part of the showcase. I'm really excited to talk to you all about the things that excite me and motivate me to keep working in the area of environmental justice. Hopefully everyone can see the slides.
Yep, good on slide.
Very good. So I just want this to be a conversation about the state of the field and in regard to air pollution and environmental justice and how those themes intersect across research and policy advocacy. So let's get started. First, I wanted to set the stage by discussing some of the definitions that we've of the words that we toss around sometimes haphazardly. So we refer to diversity, equity, inclusion, and justice at Berkeley as DEIBJ, and I will discuss the B in just a second. But for those of us that may not know the nuances between these words, justice effectively is our actions or a set of actions that are used to reduce barriers to resources, oftentimes in the form of restitution for harms that have been caused in the past. Equity is more about equal opportunity. Diversity, as we know it, is about encouraging the incorporation of all backgrounds and perspectives in conversation. And inclusion oftentimes describes the state where everyone is valued. Okay, so let's keep going. So this concept of belonging, the B that I just mentioned, I've learned more about that during my time at Berkeley from observing the activities at the Othering and Belonging Institute. Belonging, according to OBI, is more than just the feeling of being included. It's more the implementation of structural and systemic interventions that allows people to be heard across different sectors and actually see outcomes in reducing disparities. So inclusion, while I believe that can happen at multiple different scales, belonging is the outcome of the implementation of structural interventions. So bringing that back to air pollution. So fortunately, but unfortunately, we do have a justice issue within air pollution in the United States, and we'll talk about some of those drivers. And just as a little bit of a disclaimer, some of this material you may have seen before, but I'm going to be telling this story from a point of view of a retrospective thought and a call to action for what we can do in the future. So right here, we can see a map here on the right of the Green Book, or the Green Book map from the EPA, which shows at the county level what the designations for non-attainment are for the 6 NACs. Okay, so I'm focusing most of my work that I'm going to explain today on California because that's where I live and work, and we can see that, you know, that's justified because much of the state is out of attainment for 1 or more NACs. And, you know, this wouldn't be a fulfilled presentation if I didn't mention that folks at the federal government, they understand that perhaps we need to be doing more to protect human health and welfare. But this is actually a ruling that came down in February that we all heard about, where the primary annual standard has been reduced from 12 to 9 micrograms per meter cubed. As this is a health-based standard, we understand that obviously there were some implications for this change that we can talk about together today. I will reference some work that I've done collaboratively with the University of Washington, led by Julian Marshall, which shows that when we look at reductions in PM 2.5 across space and time in the United States. Overall, we've done fairly well in terms of a national average, but when we begin to bifurcate that information based on a disparity or the metric of disparity, we begin to see that policy strategies such as the NACS, which is represented by this yellow line, in terms of reducing emissions over time, we see that we don't close the disparity gap when it comes to racial, ethnic disparities, okay? It is only when we take a location or a sector-based approach, which we see in the green and blue, that we see nationally that this disparity gap begins to close as it relates to race and ethnicity. So the tightening of the standard, while it is it is very much needed. It may not address what we call environmental injustices in terms of population-weighted exposures. This is a slide I presented at AGU regarding how we think about environmental justice and where researchers can be effective. In this commentary, I put forth the notion that sometimes our incentives as academics get in the way of action-based knowledge and research, action-based research and knowledge dissemination in the form of embargoing our data, not being able to share that data because we want to be the first to say it. Okay, so in terms of environmental justice, sometimes we need to disseminate this knowledge in a timely manner because health and environmental justice issues are timely. Okay, and so once again, I wanted to just talk about a few points that may help us reframe the way we think about our work in terms of environmental justice as it relates to air quality. When we talk about justice, we really need to be focusing on work that actually pushes for a correction or a reparation of harm. And this largely comes as a result of pivotal research and pushing for new funding and new programming, new regulations to protect communities. So I will also posit that we have largely been doing environmental equity studies in terms of what we are deeming as justice within the air pollution community, because unfortunately, the harms are not corrected and reparative action is lagging behind our studies. I asked at AGU that we actually reframe our studies as environmental equity because we are looking at the differences across space and time. And if we are going to use justice in our lexicon, if we're going to frame our work as justice, I would hope that there is participatory action from those impacted and co-authorship with impacted stakeholders. And I'll talk at the end of my talk about community engagement and how that prevents us from putting forth false solutions. And I will ask that the moderators let me know when my 5-minute mark is. Thank you. I believe it's 2:10. Very quickly, every time I talk about environmental justice issues, I like to frame this from a historical context. We didn't get here by accident. This was actually quite deliberate. I wanted to pay homage to Professor Robert Bullard of Texas Southern, where at the age of 75, this was around last year, a couple of years ago, he is now receiving quite a bit of homage and recognition for the decades-long work that he's been doing along the lines of setting the stage for us to explore environmental injustices. So I just want to thank him for that. We are all familiar with, or most of us may be familiar with, his book, Dumping in Dixie. This is the book that we all cite, where pretty much he used mapping techniques to show that regardless of income, hazardous waste facilities were oftentimes sited in and near Black communities, despite the fact that they were middle and higher income. So this is pointing to race as a factor for these injustices rather than income in most cases. I also just want to remind us about how the U.S. interstate system was strategically built through less politically powerful communities, largely Black and Brown. And most of our research talks about near road impacts, health effects associated with living near a rail, 205, living near one of these highways. And so the decisions that were made to place these highways where they are ultimately led to irreversible displacement and disproportionate exposure to traffic-related impacts for those who were left behind. I also want to draw attention to discrimination in regard to where people were allowed to live in and participate in home buying. And so I'm going to draw attention to the book, The Color of Law by Richard Rothstein, that talks about this systemic de jure and de facto segregation. Okay, so last October, I was fortunate enough to sit in on a panel with Richard Rothstein and his daughter, Leah, to talk about their new book, which was part 2 of this work, where they highlighted a series of efforts that are going on in the United States to implement actionable change, okay, when it comes to this type of property-based segregation and how that then leads to more environmental injustices. Okay. I wanted to once again draw attention to deliberate upzoning in neighborhoods that are deemed or that were statistically designated as less white. Okay, this is a study from Durham, North Carolina, where Whittemore et al. Were analyzing the differences between tracts that were upzoned, and what they found was that there was no statistical difference between income when it came to this upzoning. However, the marker for upzoning, or the tendency to be upzoned, was race. Okay, so all of these factors work together to lead to compounding impacts for communities that are boxed in by policies and business transactions that lead to these disproportionate injustices. So that's the historical context that trickled down from the federal level down to the local level. I'll talk a little bit about California. So California has this pretty neat effort that was set forth in Assembly Bill 617, which called for the creation of community air monitoring plans, camps, and community emissions reduction plans, or CERPs. This right here is just a definition of what those CERPs are supposed to encompass. Over here on the left, I'm showing the different communities that have been designated as AB 617 since 2018. There are many more communities that are not under this program, but are in desperate need of specific emission reduction strategies to address the unique disparities that are going on there. So let's move forward. I also want to draw attention to something I talked about at AGU in regard to how climate and meteorology are working against some of these efforts to reduce air pollution. So essentially, rising temperatures are going to be leading to the formation of more secondary air pollution. So we actually have to be mindful of how climate is going to exacerbate disparities. So I want to bring it back to what is being done in California, specifically Southern California, in regard to air pollution and subsequent disparities, specifically health disparities. The multiple air toxic study is an ongoing risk assessment that happens every 5 to 6 years. Essentially, the South Coast Air Quality Management District analyzes the risks associated with different air toxics, such as diesel air pollution, and you can see their equation for risk here. Right here on the left, you see a plot of a model, a chemical transport model driven diesel PM, and what an example of a cancer risk map or a change in cancer risk over time. So let's get into that a little bit more. I'm showing here results from MATES 4, which was completed around 2015. What we see on, let's start on the right, is the absolute revised cancer risk based on the Cal OEHA definition. And if you look at this, you can see that the highest cancer risks are coinciding with the transportation network. Here on the left, they are demonstrating that there are differences, meaning reductions in this cancer risk that occurred between 2005 and 2012. Here I'm showing the MATES 5 study, which, excuse me, it's not 2015. This MATES 5 actually wrapped up around 2019. We see here on the left, this is the MATES 4 map update, and on the right, this is the MATES 5 update, and we're seeing this higher impulse near the port. Okay, this is the port of Long Beach. But still, the highest incidences of cancer risk are over the rail network or over the transportation network. And we've already set the stage for thinking about how placement of interstates, housing laws, all led to this boxing in of cancer risks near those areas. I also wanted to draw attention to how the AB 617 communities coincided with the MATES 4 map. So this is the San Bernardino Muscoy AB 617 community. This is near Los Angeles, and this is the Port community designated AB 617 community, and we see here that they have a really high concentration of cancer risk. I'm drawing attention actually. Let's keep moving forward. What I've been talking about may seem retroactive and historical in nature, but this is actually an ongoing issue. Unjust zoning and upzoning is still going on in Southern California, largely in inland Southern California, and that is related to the expansion of the logistics industry, big box industries in Southern California. Many people have heard me talk about this quite a bit. I'm going to acknowledge the community-driven report led by my now PhD student Yvette Torres, who was then a community organizer with the People's Collective for Environmental Justice, where they used mapping tools to show that warehouses are in and around sensitive receptors like hospitals, elementary schools, and that obviously for the convenience of the logistics industry, they build these warehouses near the road networks, which leads to compounding impacts that are already present from transportation-related emissions. I also want to acknowledge grassroots media organizations that are bringing light to these issues. A lot of times these issues are unbeknownst to researchers because we sometimes don't get a chance to interact with folks that are on the front lines. But I will talk later about why it's important to collaborate with such people. I wanted to take a look back to bring us back to how we saw these overlapping disparities in Southern California and across the United States, such that when we do have compounding environmental injustices in certain locations, it oftentimes correlates with health injustices. This is a study that we carried out in 2021 that showed the overlapping nature of COVID cases in Western Riverside County and the more detrimental Calen screens overall environmental risk score. So the higher COVID cases were related to the higher environmental injustice score. That also coincided with racial ethnic demographics in this location as well. I pulled this information back in 2021, where I also showed that this was in a presentation at the NSF for pandemic prevention. Vaccine inequities were also seen during this time. There were racial ethnic disparities, despite the fact that Black and other people of color were disproportionately impacted by COVID. We also saw this disproportionate vaccine rollout when it came to income as well, and this is Los Angeles County. I want to draw our attention back to the fact that these unfortunate events like COVID have compounding impacts, and oftentimes we can narrow these compounding impacts back to race and ethnicity. This tends to be the overlapping indicator that leads us back to the highest impulses or the highest disproportionate impacts across all of these different factors. All right, we've already talked about this, but I'm just showing once again a similar plot of Calen screen and COVID that inspired our work, and this is for Los Angeles versus the work we did in Riverside. Also during this time, I understood that land use disparities was driving these inequities and subsequent air pollution disparities. So I'm just showing a few images here of what we see in inland Southern California. It's quite jarring, and sometimes we may not see this in other places in the United States. Right here, we can just see acres and acres of warehousing right next to a community that's boxed in by this expanding logistics activity. Also, on a toxic tour back about 6 years ago, I stood on the street, and this community has been disproportionately impacted by the BNSF rail yard and subsequent cancer incidences. And this is an old bus refueling facility, a natural gas refueling facility that they were fighting to get shut down due to these high cancer incidences. So these are the types of things that we see in California for those of you guys that haven't spent a lot of time out here. This is the BNSF rail yard that I talked about. And you can see here that the rail yard goes for blocks and blocks at a time, and it's right across the street from a soccer field where community members use the soccer field at length, and there are cases of non-smoker cancer, okay, simply because of where they live, play, and work. I'm gonna move forward through some of this information that's redundant. So I want to draw attention to a study I did here that poses that that we actually have to take into account human mobility when we talk about exposure. And sometimes this home-based proxy may underestimate how people are exposed outside of the home. And we can do that by using wearable sensors. And so this is a tool that I use quite often to incorporate into my research. And subsequently, we're able to support community-led efforts. So the APT sensor has a very nice vendor dashboard. So APT gives us this dashboard where we can see time resolve concentrations with the device, as well as spatial clustering. We have done some research in San Bernardino near the rail yard, where we are looking at the personal exposures of community members that live here. I want to call attention to the fact that this is a burden of proof study, and I'll show you later how we use the outcomes of this work to drive policy change. We wanted to collect indoor and personal measurements to understand how communities are being impacted by the BNSF rail yard, which has already been shown to have a disproportionate cancer risk in and nearby. This was a community-led study where we worked with folks over about 6 months, and we did personal monitoring in 1-week increments. And then we also did purple air monitoring the following summer. I'm showing here, this is the rail yard right here, very in this boomerang looking shape. And I'm showing here that we see the highest impulses of personal exposure to PM 2.5 closest near the rail yard. This is showing how we divided up that information by microenvironment using a GIS clustering approach. And we see here that the red microenvironments are the highest, but we also see that non-residential exposures can also be quite high. I'm moving through this because I want to get to the actionable part. So we also did some purple air monitoring, and we can see that those indoor measurements have a tendency to have higher spikes, as we can imagine, due to cooking and so forth. If you want to read more about what we've done, please go to my website, ivylab.com, and check out our preprint, which is now under revision. I want to also draw attention to the fact that the community understands that they're overburdened, and they typically view their well-being in regard to their lived experience as fair or poor. I'm sorry, fair or good. We have actionable items associated with this work. We distributed community resilience plans based on the community's measured personal exposures. And we found this to be a very effective way of reporting back that information. So you can see here that we showed them their microenvironment-based exposures over time. I want to draw attention to the fact that the work does not stop at the local level. So since I do research alongside community organizers, we do have the opportunity to present our work at in front of federal audiences. This is Yvette Torres, who led the Warehouse Report. She was invited to speak to the Senate Subcommittee on Clean Air, Climate, and Nuclear Safety as part of the new Moving Forward Network, where she talked about our study. And this was a hearing on opportunities for reducing emissions for America's rail network. So rail is becoming an emerging environmental justice issue because of all of the cargo associated with logistics that is being moved through these intermodal facilities. I would just want to briefly put here the broader impacts from NSF. We all understand that, but I actually want to quickly put some of these points and questions up here where I'm interrogating our research motivations and outcomes and the way we traditionally think about broader impacts. I know this is recorded, so hopefully you guys can go back over this, but I'll just draw attention to one. When we think about air pollution and environmental justice work, we oftentimes need to ask ourselves, are we members of the affected community? Do we have lived experience and cultural competency, which is becoming more and more important? Because unfortunately, when we don't have cultural competency, as researchers, we tend to put forth false solutions when it comes to environmental justice and mitigation. I want to call attention to a special issue that I'm leading in environmental research letters, where we want to highlight the work that folks are doing at the intersection of community engagement, which brings in that lived experience, and environmental engineering. So it is often important for us to understand that there's a continuum in terms of environmental justice and community engagement. I think that studies that don't have community involvement oftentimes miss a lot of those cultural confounders. And so for those of us that want to implement justice in our work, it may be important for us to build in more participatory activities. All right, please check out my call to action and environmental health perspectives. And I'm going to actually leave the slide here. And I just want to encourage us to think about our work in terms of how the outcomes can lead to reparative action and how our work can better incorporate the voices of those who are most disproportionately impacted. Thank you.
Thank you so much for the talk. I'm gonna actually just build right off of where you ended here to ask what in your in your opinion is an example of a false solution that you might come to if you were not a member of a community who's impacted? And then could you also share, you highlighted some in your work, but could you also share a few more examples of outcomes that you would describe as being aligned with reparation for these environmental hazards that researchers
Yeah.
could include in their research process?
That's a very good question. So one really glaring example of a false solution that came up in California is cap and trade. So essentially, it was a market-based solution to reducing carbon emissions, but unfortunately, it allowed the biggest offenders to just buy off their, reductions. What was the second question?
Sorry, the second question was, so yeah, what would be an example of other types of outcomes, like action-based outcomes that researchers could incorporate into their methods so that the research actually goes into reparation for the environmental hazards beyond describing the environmental inequity?
Right. So honestly, as researchers, I think the best thing we can do is to work with folks that are on the action-oriented side. So the way it goes is we produce the data-driven evidence, and then we work with the organizers, the lawyers, the regulators to use that evidence to drive new policy. So oftentimes we aren't on the action side, but we can work with those people that do that. I hope that answers the question.
For sure. Greg, I'll pass it to you.
I just have a quick question about redlining and the big movement around trees, your thoughts, and the lack of movement around the social injustice side, dealing with the longer term issues around that.
Trees, I guess you're talking about green infrastructure and
Yeah.
urban canopies. Um, that was also deliberate. There was a deliberate a disinvestment in that type of greenery in redline communities, so C and D grade communities. And you asked about why we haven't seen long-term change.
Well, my question is trees are, this whole thing about greening is like exploding, but I haven't heard a lot in terms of dealing with those inequities, because people are dealing with a lot in redline communities, not just, the fact that the temperatures are warmer. So I haven't heard a lot about other aspects of what we need to be doing.
So yeah, it's actually quite dire. I mean, the homes that are boxed in formerly redline communities, and so it's really hard to disentangle or to reverse all of that because it was baked into mortgage, housing, urban green. It was baked into all of that. So um, I think there's just a general unwillingness to put the resources toward that from a top-down sense. A lot of people or a lot of organizations want this to be like a bottom-up solution, like put forth more local funds to green whatever. But a lot of these unjust policies came down from the federal government. But I will give a shout out to, sorry, the EPA, which is funneling a lot of money, a lot of resources into these like reparative grants. So I would say that's it's on the way through those grants. But there needs to be massive investment in trying to correct all of that. And we probably need to be doing it now.
Thank you. We can take
Sure.
questions from the audience. Feel free to just raise your hand. I see Morgan right now. Feel free to unmute.
Hey, yeah, thanks so much, Suni, for your talk. I was looking at the MATES results from 2015 to, I think you said that it ended in 2019 for the second one.
Yeah, I need to go back. Mates 5, I think, just wrapped up. It was recent.
Okay.
Yeah.
Excellent. Now, maybe I was being too optimistic, but it almost looked like there was an overall reduction in cancer risk between those two time periods. Is that correct? And if so, what do you think led to that reduction?
Yeah, that's a great question. Okay, so diesel PM is driving the cancer risk. So in the last 10 years, they have implemented some state measures to reduce NOx and PM from diesel trucks. So selective catalytic reduction and diesel particulate filters. Compliance for outer state vehicles, so the enforcement of those state rules gets a little bit gray. But I would say it is because of some of the aggressive measures from CARB. I worry because of the explosion of the logistics industry and this interstate commerce, how effective those control measures are for folks coming out of state. Yeah, good question.
Thanks. Do we have other questions from the audience?
We have one question in the chat.
I think it was more of a comment than a question. But Sona, appreciating your talk and echoing that the same issues are going on in Memphis. And also, I think just connecting to what Greg was saying, was kind of a comment/question about like, should governments be investing in tree planting, which is essentially kind of a band-aid, as opposed to addressing the fundamental issues such as, you know, energy, industry, et cetera, that are producing these inequities in the first place. But I see a question from Lena. You want to go?
Yeah, hi. Thank you so much. This was really, really interesting. And I'm looking forward to reading more of your work. I'm wondering if you would actually be up for talking us through an example of when you've seen, I think you maybe referred to it as false conclusions being drawn from people who are attempting to conduct environmental justice research, but aren't actually from the community they're doing research in. If you're up for talk, I would just really like to hear from your perspective something you've seen, and then how those people potentially could have rectified or improved that situation, or their approach, I guess.
I don't know if I can do it without
Yeah.
I've just seen a case specifically where someone outside of California applied a model toward the impacts of transportation related to warehousing, and their model saw no significant impacts from that heavy duty movement related to warehousing, which you know, in terms of models, garbage in, garbage out. And so since, you know, they don't live there and they can't, they aren't counting those trucks. And also those trucks are on arterial and local roads. And so we don't have monitors for vehicle miles traveled on local roads. And so they wouldn't know about the idling, the illegal idling that happens near people's neighborhoods. They wouldn't know that. So their models are probably going to be wrong. And so if that model says there's no impacts, then there will be no subsequent action to reduce that.
Thank
Yeah,
you for
thank you.
bringing. Oh, sorry. I was just gonna say thank you for bringing that up. I think it brings up a really important issue that I might add on as a call to action, not just like in framing environmental justice action or in environmental justice research or trying to contribute to that. I think we researchers have ethical obligations to the communities that we're wanting to study. And in some cases that might look like not publishing a study that could actually inadvertently have more harm to community, that you don't have a lived experience being part of, et cetera, et cetera. So thank you for bringing that up. Azar, how are we doing on time?
We have 1 more minute.
Okay, Morgan, go for it.
Awesome. Thanks for squeezing me in. I was curious, when you are doing community-based work and talking to community members, what are some of the concerns that they bring up to you and things that they say, and how do you address those?
Yeah. Some of the things I've heard recently, so I hopefully will have more published work in terms of what's going on in the Bay Area, which is a whole different issue. It's a big NIMBY issue here. But in terms of Southern California, they are mostly challenged, or they're mostly concerned about local land use decisions, so upzoning, which is allowing the permitting of the warehouses. In the Bay Area, I would say it's more Superfund related, so a lack of willingness to clean up things that were historically there. So land use decisions in Southern California and a lack of willingness to address historical issues in the Bay Area. Concerted.
Thank you so much. If we could all give a virtual round of applause
Thank you.
for the talk, and thanks for the questions. And I'll pass it back to Azar. Thanks for joining us, Dr. Ivy.
Thanks.
Thank you, Dr. Ivy, for this compelling talk and for the great discussions after that. Now I would like to hand it over to my colleague, Jennifer Vanos, to moderate session 3. Jenny, please take it away.
Thanks, Azar. I want to ask first, is Jesse Bell on? I don't see him here. He's our first speaker. So, well, I'll get the session going, and then Karina Chung, if you're okay going first, since Jesse's not here, I'll give you a minute to get ready. Oh, good, you're there. Okay, so thanks everyone for being here. This is session 3 of the AGU AMS Climate and Health Showcase. And we have quite a few great speakers lined up to do 5-minute e-lightning talks, and then we'll hold questions till the end and have time to do a discussion with all the speakers at the end. So we'll go through each talk very quickly, and I'm going to start with Karina Chung from Harvard University, and then if Jesse joins, we'll do him next. So Karina, you should be able to share your slides and take it away.
Awesome. Thank you so much for the introduction. Can everybody see this?
Looks good. You just have to go share them like big. Yep.
Great. So good afternoon, everyone. My name is Karina Chung. I'm an undergraduate working with Harvard's Atmospheric Chemistry Modeling Group. And so for the sake of time, I'll jump right in. Due to climate change and aggressive fire suppression policies in the 20th century, wildfire activity in the Western US has accelerated dramatically over the last 20 years. The plot on the left shows area burned as a function of aridity in the Western US, measured through vapor pressure deficit, or VPD. The color-coded circles represent time ranges, and we can see that over the last 20 years, as shown by the red circles, both area burned and aridity have increased. Area burned and aridity reached extreme levels recently in 2021 and in 2020, which was the most severe Western US wildfire season within the recorded period. It's important to note that the impact of these extreme fires stretch far beyond the line of fire in both space and time because of harmful PM2.5 pollutants contained within wildfire smoke. These cause large-scale public health impacts, most prominently in the 12-month aftermath of the fire season. However, current land management practices are not effectively accounting for smoke exposure because we don't have the quantitative tools determining which areas to target in order to reduce smoke exposure. So in order to understand these health impacts a little better, we first analyzed historical data to understand the impacts of smoke exposure on human health. Our median estimates attribute over 50,000 excess deaths to smoke PM2.5 exposure from Western US fires in the aftermath of the 2020 fire season. The plot shows our excess mortality estimates all the way from 2003 to 2021, categorized by subregion as shown in the map. The first thing you might notice is that this plot is very colorful. So of the subregions are represented in at least one fire season. So this indicates that the adverse health effects from Western US fires are traveling all the way to the East Coast. Nevertheless, the vast majority of excess deaths in the 12-month aftermath of Western US fires occur within the Western US. In 2020, the worst fire season, like I mentioned, 1,838 excess deaths occurred outside the Western US. That only represented about 4% of excess deaths. And so the other 96% occurred within the Western US. And so we decided to choose this region as our region of focus moving forward. Currently, we can analyze this historical data and provide estimates, but we don't yet know how to project smoke risk and impacts on human health into the future when we don't know the fire emissions. So our work seeks to address this need using an established geoschem-based framework to assess population-weighted smoke exposure in Northern California. Geoschem is an air pollution model which accounts for the transport of smoke PM2.5 pollutants due to wind and weather patterns. We take fire emissions from the Global Fire Emissions Database, as well as population-weighted sensitivities from the Geoschem model to multiply them together and obtain a population-weighted smoke exposure. However, to project this framework into the future, we have to take a new approach. So we present Smart Flames, an online tool deployed on Google Earth Engine that uses area burn scenarios to project which areas will pose the greatest risk to smoke exposure for populations downwind. Suppose it's 2019, and we're California's land management team. We're interested in predicting smoke risk in 2020. And based on our initial assessment, because we are experts, we think that 3% of the savanna and 3% of the forest across Northern California will burn. We can then input this assessment into Smart Flames, where land cover data and our projected burn scenario are related to a potential emissions value for each grid cell. Once we have this potential fire emissions value, we use emissions factors to isolate the harmful PM2.5 pollutants within wildfire smoke. This converts the potential fire emissions value into a smoke emissions value for each grid cell. Finally, we can multiply the smoke emissions by the sensitivity as shown to achieve a smoke risk index at 0.25 by 0.25 degree resolution. So this is our projected smoke risk index in Northern California using weather patterns, so the sensitivity from 2020. We bin each grid cell into an index, and so we label each grid cell with a smoke risk level from 1 to 6, so low to extreme. Within the extreme risk region, the red outlines indicate the areas that pose the greatest risk to population-weighted smoke exposure if a fire were to occur in that region. Notably, most of these highest risk grid cells lie in suburbs of major Californian cities like San Francisco and Sacramento. These are within the wildland-urban interface, so those are areas where human development meet forest or other flammable vegetation. Fires, especially within these areas, often cause the greatest damage to surrounding communities, and Smart Flames actually tells us that targeting those areas and preventing those fires will also have the most impact on reducing smoke exposure and its associated health impacts across Northern California as a whole. So, in conclusion, we create Smart Flames. It's a flexible framework for land managers to target specific areas that minimize smoke exposure under area burn scenarios. We hope our work can help inform future land management practices that account for and reduce smoke exposure. Thank you so much for listening, and I welcome any questions.
Thank you, Karina. If you have questions, you can feel free to put them in the chat or hold them till the end of the session after all the 5-minute lightning talks are done. So we're going to move to our next speaker, Dr. Jessie Bell from the University of Nebraska Medical Center. Jessie, you should be able to share your slides now and get going.
There we go. Does that look okay? Are we on the right?
Go to your swap displays button up at the top left.
Oh,
there. Yeah.
All right.
There you
Well,
go.
thank you. Sorry for being late today. I apologize. I had the time change, our time difference messed up. So I want to talk about some of our work that we've been doing around understanding the impacts of drought on human health. This has been a large effort by multiple different teams and entities across the US to try to better understand how drought is impacting human health. And so I really appreciate all of their help and support through this. So we have a current project that's being funded by NASA through their health and air quality program, looking at how we can better utilize satellite-derived drought monitoring tools to understand changes in air quality and what does that mean for human health outcomes. And our ultimate goal of this project is to create tools for decision makers to help with drought preparedness and response. And the basic premise or the overall goal of this is to really make sure that we're improving our public health preparedness and capacity for addressing drought impacts, because droughts are pretty significant here in the United States. However, when we talk about droughts, a lot of times we don't talk about it in the context of health. We talk about droughts in the context of water resource management or agriculture. But there have been changes in conversations around drought actually having impacts on human health here in the United States, in particular focused on some of those states that have been more recently impacted by major drought events. Droughts difficult and different than many other climate and weather related disasters. Droughts are slow evolving. They don't have an immediate onset like a heat wave or a flooding event or a hurricane. The impacts are not immediate. They can require multiple steps before you see human health outcomes to occur because of droughts. And health surveillance systems are really not designed to look at the impacts of drought on human health. So there's some more complexity to understanding some of these relationships. But drought is a threat multiplier. In particular, I want to talk about the context of drought in impacting air quality. Droughts lead to drier conditions, which can lead to better conditions for wildfires. Droughts can also decrease air quality through a variety of different means, which then can lead to adverse human health outcomes. We've done some initial work trying to understand some of these relationships, and we've seen an increase in respiratory-related mortality across the United States and certain parts of the United States associated with drought events. Each of these states that you're seeing here listed in red are states where we saw an increase in respiratory-related mortality over around a 20-year period associated with drought events. And all the states that are identified is where we found statistically significant increase in respiratory-related mortality. Not only that, we were able to actually dissect that down a little bit further and notice that we found an increase in female and male respiratory-related mortality with extreme drought events versus the more moderate drought events. And we found that females were more impacted or had a greater significantly increase in respiratory-related mortality. We also noticed some differences between rural and urban. Again, extreme drought events were more impactful. Rural populations were more impacted, had a greater significant increase in respiratory-related mortality versus our urban counterparts. And so this kind of gets at, we need to better understand what is actually going on and digging a little bit deeper into some of these numbers, because we found an increase in respiratory-related mortality. We're understanding some of those demographic shifts that we're seeing, but we want to better understand what are the changes and what are the actual associations for respiratory-related mortality. And that's some of the work that we're doing currently. We're also wondering what is actually going on. Why is the respiratory-related mortality increasing with drought events? What is the actual change in air quality during these events? And so that's some work that we're currently going through. One of the next steps, which is what we're going to be doing this summer, is hosting workshops with decision makers. So we're going to be bringing in public health experts from across the country that have been working on drought and health related issues and present some of our results and present some of our tools that we've made to better understand what are their needs, what's the gaps of information, and what are the opportunities moving forward to collect that information from them to make better tools and resources for their populations. We have a number of different partners that we've been working with around this issue. And one of the tools that we've made, which is actually just being released today, is a drought and health messaging toolkit. This was made in partnership with the Nebraska Tracking Program, with NOAA, and with other agencies and entities as well. And the whole premise of this is to develop a toolkit, a messaging toolkit for public health and healthcare professionals on drought impacts on human health. And so the basic premise is it provides general information for public health.
Excuse me, Dr. Bell, could you please quickly summarize? We are a little bit out of time. Thank you.
Drought is associated with respiratory-related mortality. It has impacts on greater risk of respiratory-related mortality. We're trying to better understand some of these relationships, and we're hosting workshops in the future to understand some of these relationships as well. And so if you're interested, feel free to reach out to us. These are our funding partners, and that's our information as well. And so thank you so much.
Thanks, Jesse. That was great. I appreciate it. All right, so we're going to keep chugging along to our next speaker. We have Caroline Reed of IC Change talking about data for informing local policy on heat and health. So Caroline, I think I saw you here. Please go ahead and share your screen.
Thank you so much. Thanks for having me. I'm Caroline. I'm here today to talk about a presentation, or excuse me, a project in collaboration with Johns Hopkins University. And I think many of you heard from my colleague Lena earlier at the RAND Corporation as well. I myself am with IC Change, and we're a data and engagement platform that allows residents to provide climate impact stories in real time. So we are based out of New Orleans. We are working across the United States and even internationally, but we've used the platform and collaborated, just for a little more context on our work with extreme heat in New Orleans, to work with low-income renters across the city to share impact stories about how heat's impacting their lives, and also host heat sensors indoors. During this first initial wave, we were able to identify some really key concerns, such that indoor conditions were often hotter for residents, and that the National Weather Service was under alerting, especially in specific neighborhoods over the course of the summer 2020. This data, the goal for collecting this data is for it to motivate policy and other solutions, and it helped inform the city of New Orleans' first cooling standard at 80 degrees Fahrenheit. So that's the limit that is suggested that homes be kept beneath to be safe and habitable. That inspired the work that I'm here to talk about today with our collaborators at RAND and Johns Hopkins. So you may have heard a little bit of this earlier, but this past summer, we began the first wave of the study. We were extremely grateful to be able to work in the Florida Desire area in New Orleans. We did this through partnerships with Thrive NOLA, who is an amazing community organization, and through partnerships with advocates in the area who are helping us lead this study. We've recruited and compensated residents to do a number of things. So firstly, answering surveys to learn more about their background related to heat-related risks. So their conditions at home, energy bills, health, and then we were doing daily survey launches to understand how heat was impacting them throughout the day for 2-week periods over the summer. Lastly, we were hosting sensors in the home to understand how extreme heat was impacting people, most notably in their bedrooms, because that's where you're sleeping and you're spending a majority of your time. Just some interesting things to dig into. This neighborhood and I'll actually flash back to that. This area in the Florida Desire area, it's next to a Superfund site. It's along the railroad tracks. There are not nearly enough trees. There are all of these conditions compounding and making life difficult. And on top of that, this is an area that is very under-resourced and household incomes are often limited. Nearly 60% of the people in the study were at this lower level. But one really concerning thing we found was that the average energy bill was somewhere around $350 a month. The cost burden of that on residents is something that's extremely concerning when you're having populations and people that are faced with choosing between health and your ability to finance your energy bill. This isn't rare or exclusive to New Orleans. We've seen through previous studies that nearly a third of residents across the South struggle or can't pay for their energy bills. And that in New Orleans in particular, up to 50% of your energy bill during those peak extremes throughout the year goes to paying for your heating or cooling. When we looked at some of the sensor data and we compared it to the cooling standard set at 80, we found that around 25% of residents in this preliminary data were shown to be above that suggested safe level. We also saw some trends where that central AC seemed to do a generally better job than other air conditioning units like window units. Another interesting thing just to kind of dig into, we have previously worked more with renters, and we had presumed that that might be a group that's more at risk, but we were able to have a pretty decent split between homeowners and renters, and found that homeowners just face different challenges. Upkeeping a home, keeping it well insulated, keeping it energy efficient, especially in a place like New Orleans that undergoes frequent natural disasters and has a lot of old homes and old builds, can be really challenging. And through impact stories and through the preliminary data, we've seen that come out as well. Just to put a few things into context, our goal through the study, which will continue next summer in a different neighborhood in New Orleans, is to be able to transform the data and the stories into solutions that are bringing resources back to these neighbors, that are sparking changes in policy, and in general, just making us think more about this governance gap when it comes to extreme heat. There's often not a dedicated budget for heat on the local level. And so it's important to us to just flag this as a growing concern and a really high priority. Lastly, just a thank you to all of my collaborators who have made this such an amazing project going forward. A huge shout out to the residents who made this possible, to our community advisory panel, collaborators at the health departments, and also at the NIEHS. Feel free to reach out if you have questions, and I'll stay on as well.
Thank you so much, Caroline. Yeah, we'll hold our questions till the end, but please feel free to put them in the chat as well. So let's move on to our next speaker. So our next speaker is Jane Baldwin from UC Irvine, who will be overviewing humidity's role in heat stress.
Great, can you see that? All right.
Yep.
Okay, awesome. Hi, my name is Jane Baldwin, assistant professor at University of California, Irvine. So today I'm going to be giving a presentation called Humidity's Role in Heat-Related Health Outcomes, a Heated Debate. I originally gave this at the AMS meeting this year. Also, if you attended this showcase last year, you might have seen parts of these results in the keynote presentation I gave, since this work has been published. So hopefully it's useful to see the highlights of it once again. So this is a highly interdisciplinary project, and what we were trying to get at is what we see as a key challenge for projecting the health outcomes of heat in a changing climate, and that is that health researchers fundamentally do not agree on the role of humidity in heat health outcomes. So with climate change, we know that as greenhouse gas concentrations rise, the temperature of the Earth increases following the greenhouse effect. In addition to that, because of the Clausius-Clapeyron relationship, as that temperature rises, the amount of moisture in the atmosphere also increases. Now, epidemiologists and physiologists are two of the key health disciplines that have sought to understand the relationship between temperature, humidity, and other environmental variables and health outcomes. Epidemiologists tend to use strategies such as taking a large population of individuals and comparing outcomes, health outcomes in that population, such as mortality, to weather data, such as temperature or humidity. And they perform a time series analysis, and what they tend to find is that temperature has a close relationship to mortality. However, humidity has limited, if any, added value in predicting mortality in the heat. In contrast, physiologists use other strategies, such as putting people in thermal chambers or doing energy balance modeling to seek to understand the relationship between temperature, humidity, and human health. And what they find is that humidity is a key predictor of health outcomes in the heat. And that's because humans primarily cool themselves through sweating. So when humidity is higher, that ability to cool oneself is lessened. And as a result, core body temperature can increase, which leads to a cascade of health problems. So let's say I'm a climate scientist, and let's say you're looking at this information and trying to combine it with climate projections to try and understand what's going to happen to people in the future in the heat. Well, you might get vastly different projections depending on if you take the epidemiologist perspective and just predict heat health outcomes based on temperature versus the physiologist perspective and predict it based on temperature and humidity. Additionally, the patterns of that change over space might vary considerably because humidity, for example, has more of a tropical amplified change with warming than temperature. So in this paper, our goal was to reconcile the differing viewpoints regarding humidity to ensure robust projections of heat health outcomes with global warming. As we started discussing, we realized that the reality is this issue could stem from a wide variety of problems. And so as an interdisciplinary team covering epidemiology, physiology, biometeorology, public health, and climate science, we put forward hypotheses for the physiology epidemiology disconnect around humidity. And what our hope is, by kind of problematizing this issue and putting forward these hypotheses, ourselves and the rest of the community, so hopefully some of you listening will be able to take these hypotheses, test them, and we'll be able to have more robust heat health outcome projections in the future. I don't have time to go through all the different reasons we hypothesize. I encourage you to look at our paper in environmental health perspectives if you're interested in for more details, but I'll give you some highlights. We broadly group these hypotheses into either physiological reasons that could explain a more limited effect of humidity than is conventionally discussed by physiologists, or possible causes of bias in the epidemiological studies that might make it seem like there's not an impact of humidity when in fact there is. One physiological reason I want to highlight is that many common deaths or hospitalizations due to heat are from cardiovascular disease, which really has a strong relationship to temperature, but has a more indirect relationship to humidity, in contrast to, say, conventional heat stroke. An analytical reason the epidemiological studies could be biased is that there's a rather high correlation between temperature and humidity and many different parts of the globe where we have epidemiological records, which might make it difficult to distinguish their differential effects. And finally, on the data-related side, there are limited epidemiological and weather data from lower and middle income countries and the tropics, where people are likely most vulnerable and moist heat tends to be high. So again, I really encourage you to check out our published paper if you're interested in learning more. If you have ideas on how to resolve this debate, please reach out to me, or if you have any questions. And finally, I want to very briefly say I'm the program chair of the AMS Conference on Environment and Health this year. It's part of the AMS annual meeting. It's in New Orleans. I strongly encourage you to submit sessions due April 25th, submit abstracts for presentations due at the end of the summer, and reach out to me with any questions. Okay, done. Well, thanks.
Thank you, Jane. That was great. Lots to cover, and thanks for promoting our conference next year. Okay, let's keep moving to our next speaker. So our next speaker is Austin Rao of the University of Minnesota, who will be going over compound drought and heat waves with mortality. So please go ahead and share your screen and take it away.
Great, thank you so much. And the Zoom toolbar is hiding everything. There we go.
There you go.
All right, great. Well, thank you so much. Yeah, my name is Austin Rao, and I'm presenting on the associations between compound drought and heat waves with mortality among individuals with COPD. This was completed as part of my dissertation research that I recently finished. And so the study was really motivated by the summer of 2023 was just an exceptional season. There's several different extreme weather events happening across the country. And it's important to recognize that these aren't happening in a vacuum. They're not isolated from each other, and that there may be situations in which there are 2 or more events happening at the same place in the same time, these compounding extreme weather events, or you could have cascading events, one happening in sequence after the other. And it's decently established in the climate health literature of certain groups being more vulnerable to these extreme weather events than others, including like the elderly, children, marginalized populations, and people with chronic diseases. But in terms of these more complex climate hazards like compound events. The public health impacts of these are relatively unexplored. So this drove the research questions I investigated, which were how much larger is heat wave associated mortality during drought compared to non-drought conditions among people with chronic obstructive pulmonary disease or COPD, and if these associations vary by the timing, so like an early versus late warm season occurrence. So this study used data on about 183,000 veterans with COPD from across the country and used data from GridMet and the USDM to measure both heat waves and drought and compared binary drought, no drought versus drought, and then a categorical drought definition, and used a case crossover study designed to measure the associations with heat waves and mortality stratified by these different drought levels. And so what's interesting is even just in the summary statistic results, we found some very interesting results with heat wave temperature and duration stratified by different drought levels. And there's this clear pattern of heat waves becoming increasingly hotter as drought becomes more severe. In the absence of drought, heat waves were on average just about 28 degrees Celsius, but during severe drought, there was almost a 2 degrees Celsius increase in heat wave mean temperature. And then even looking at the duration of heat waves in the absence of drought, they were about 5 days in duration on average, but during any type of drought, they were a little over 6 days in duration. Looking at the results for the associations of heat waves with mortality stratified by different drought levels, we looked at both single day effects and also cumulative effects, so over a few days. The left-hand column has our binary no drought versus drought comparisons. So you can see that there's kind of this pulling away of heat wave associated mortality risk when it occurs under drought in the orange bars compared to non-drought periods. And then especially when we look at the right-hand column in the cumulative leg panel for the categorical drought definitions, there's this nice stepped association with as drought becomes more severe, heat wave associated mortality risk steadily increased. And we estimated about 10% of deaths were attributable to heat waves that occurred under severe drought. And only about 1% were attributable for heat waves during no drought. Our seasonal analysis didn't really detect any differences for early season heat waves comparing drought and non-drought periods, which is a little interesting because the initial heat waves of the season usually elicit greater mortality responses than heat waves later in the season. For late season heat waves, there may potentially be some differences between them occurring during non-drought versus drought periods with slightly elevated mortality risk during drought. In terms of what some of this means, there's been a lot of work at the state and federal level in developing heat vulnerability indices and also early warning systems. If not already, some of these may consider including drought into their systems, because there does seem to be this joint effect of drought is making extreme heat worse and then subsequently leading to more adverse health outcomes. And just kind of more generally, I'm talking about public health research for compound and cascading events. There's obviously a greater need for that, but this will require more interdisciplinary research that aspire to have more systematized definitions of these extreme weather events to have more comparability between different studies. And then just generally encouraging data sharing and accessibility, user-friendly file formats. Some of these meteorological data sets are very difficult to wrangle with because of how they're stored. I think about centralized repositories for data, and then training on new tools like Google Earth engines that people can become more adept in using these data sets and completing climate and health analyses. So that's all I have. So thank you so much for your time.
Thank you so much, Austin. That was great. Really nice combining other talks in this session around drought and heat and so forth. So hopefully we have some good discussion at the end of this session. We have one more speaker before we get to that. Our final speaker of this session is Alicia Christensen, who will be talking about climate and mental health. So please go ahead and share your slides.
Thank you. Hi, my name is Alicia Christensen. I work for the Cooperative Institute for Research and Environmental Sciences Center for Education, Engagement, and Evaluation at CU Boulder, quite a mouthful. I'm not a climate researcher, but actually have been a science educator for the past 20 years, educating preschool all the way up to college level. And I like to take research and find ways to apply it. So over the past 20 years, I have observed in all the students that I've taught, a decrease in student connection to the natural world and a rise in a lot of mental health issues that are preventing students from engaging in science as they grapple with less time outdoors and more time on social media, more extreme natural hazards, isolation from the pandemic, violence and war, and a future that will look very different to what it does today. So I want us to reflect a second on the talks today and think about how many of them are about the negative impacts of a changing world versus how many of them are about potential solutions. I will say I'm happy to see there are a lot of talks about solutions, but there's also a lot about the negative impacts too. It can be difficult to process the emotions that come alongside all the knowledge that we hold about the future. We know that empowering the next generation into taking action can really help them deal with the helplessness and anxiety that comes up. However, the message that the next generation is starting to hear is that it's all up to them to fix these problems. And how often, I want to ask, do we stop to listen to people and how they are feeling? So I invite each of you to just take a few seconds to think about where you are on the scale created by the Climate Mental Health Network in collaboration with Dr. Penu Bakala. And if you're willing to put which quadrant you are in the chat. And I also, urge you to ask your colleagues and your students and your kids where they are on this scale. Open up the conversation. In a worldwide study of 10,000 youth published by Hickman et al. In 2021, they found that youth between the ages of 16 to 25 years felt the following. There was a lot of sadness. 67% worldwide felt sadness. 67% felt fear. 62% anxiety. 57% anger. Unfortunately, the optimism is quite a way down there. 31% felt optimistic. 4 out of 10 are hesitant to have children because of climate change. So this is kind of some heavy data. And so, how do we support this next generation of scientists and engineers and also ourselves to move beyond the doom and gloom? I support a program called the Climate Literacy and Energy Awareness Network. And it is a free, internationally known database, network, and professional development hub of lesson plans, data visualizations, and videos about climate and energy for K to college educators to use. And all are extensively peer-reviewed by educators and scientists to check for content accuracy before they're included in the collection. And as part of this collection, we have scoured the web to find existing research strategies and resources to support educators and youth as they grapple with climate change. Though I will say that a lot more research is needed in this field. There's not a lot. So you can, if you're interested in checking this out, you can look at these pages in the chat here. I can find my chat. Let's see. Goes in there for you. These resources have been organized under a list of strategies, including self-care, basically putting your own oxygen mask on first before you try to help others. Climate justice and making sure to include diverse voices in all conversations about solutions. Encouraging and taking action is definitely a big part of this, especially collective action that is local and personally relevant. Listening to others and validating their feelings, no matter what they feel, whether that's apathy or denial or anxiety. Joining and creating community, it's really helpful to not be alone in this and finding solidarity with others. Incorporating a trauma-informed approach that really recognizes traumatic actions and creates trusting environments and encourages youth voice and choice. Developing social, emotional, positive coping skills. There's a lot of self-care strategies and coping skills out there that work for youth as well as us. Looking at practicing gratitude, meditation, getting out in nature to help build resilience. Moving through grief and recognizing that feelings that people may have, including denial and apathy, can be part of the grief process. And then finally, cultivating hope and resilience. Teaching hopefulness is actually a teachable skill. And doing things like helping people to reframe negative thoughts to be a little bit more objective. Is the whole world doomed? No. Is the world going to look different to what it does today? Yeah, probably. This is kind of data that brings me hope, and I feel like isn't shared enough. In that, we do contribute heavily to climate change, but it does bring me hope.
Excuse me, Alicia, could you
Yes?
please quickly summarize? We just
Yes.
want to ensure enough time for Q&A.
Okay. Yes. Okay. And so anyway, we found we had created some short activities as part of this effort, and teachers responded with being very surprised that their students wanted to listen so much or wanted to talk about their emotions so much. So I encourage you to do the same with your colleagues, your kids, your friends, your family, and your students. Thank you.
Thank you so much, Alicia, and sorry to rush you through that. So for everyone on the call, we have time now, about 10 minutes for question and answer with all of the speakers that spoke over the last 45 minutes or so. So I encourage you to turn on your cameras, put your hand up, ask questions, or put your questions in the chat. I'm happy to ask them for you. And while we wait for questions, I guess I'll jump in and ask the first one. I'm going to start with Alicia, because I really, really am thankful that you brought up this topic. And I think a lot of researchers forget about the fact that we can't just show all the bad without providing solutions and actionable adaptation, mitigation strategies that are actually occurring in real time. And it makes me think too of our environmental justice keynote speaker who was also on earlier, and how it's important to not just be collecting data that might show high exposure levels, but also providing solutions to those exposure levels, whether it's around air pollution, heat, drought, and so forth. So Alicia, I was wondering if you had any examples you could share around some of these topics that have been brought up in this session, where maybe it's more of a short-term issue on the weather scale, not climate change per se, but that a solution was formed and really made a difference in kind of the reframing of challenges for students. If you have any examples. Or if you even not an example,
Yeah.
but a way people might do that with their research.
Yeah. I think, I definitely push people, I think, to listen more. I think whenever we're communicating about our research, I think it's helpful to just open up the conversation about how this is making people feel, because otherwise it gets pushed under the rug. And students are hearing about this in school. They're hearing it, of course, outside of school as well. So I think opening up the conversation is really helpful to get things started. But I think there's a lot of examples out there of students taking action. I don't know that I have like a specific example of students taking action related to a specific research. But I'm sure that there are a lot out there. I mean, students in schools are being pushed to really find solutions and take action.
Yeah. Yeah, it's important, I guess, to think about how some data can empower people, whether it's a student or a community member, to speak up, have a voice, feel heard with a lot of these environmental and climate issues we're bringing up today. I'm going to open up for one more question from anyone in the audience that you might have on drought, on heat and humidity, on indoor heat, and any of the methods shared in the last session.
I have a question for Jesse. Jesse, if you are still on the call. So you showed a great messaging tool that your team has developed. And can you talk about how you are planning to disseminate that messaging tool to vulnerable communities?
Sure. Yeah. So I've been really proud of how that kind of came together. For me, it's one of those examples of actually doing research, engaging with the community, and then creating a product based off of some of our communications with the community as well. We are in the process of disseminating that. We've got a multiple different prong approach. Everything from working with the Centers for Disease Control and Prevention on providing it to state and local health departments, doing a webinar that's going to be providing this as well and providing this information. And then we have a number of different resources and entities that we're going to be working with as well, and different organizations that we're going to be working with as well to provide that tool. And then not only with providing the tool, the next piece that we really want to do is get feedback, because we want this to be a living document so that we're not just creating it and throwing it out there into the wind, but making sure that we're getting feedback on things that people would like to see improved, and working with local health departments in particular to make sure that we're improving that document. And that's one of the things we'll be working on over the next year.
Perfect. Thank you so much. That's exciting. And it's nice that a lot of this you said just kind of came out today. So it's good timing. We do have a question in the chat. I think one might be for Jesse and then another one for Caroline. We do have a break now, so I'm going to allow the speakers to answer those questions in the chat. We'll go for about a 15-minute break. So we'll come back here at 3:15 p.m. Eastern time. So I'm pushing the schedule back by about 5 minutes. And then we have our final keynote speaker, Dr. Chris Ebi, talking around climate and health and adaptation. So hopefully you can all hang around and join us for that in about 15 minutes. And yeah, hopefully speakers can stay on and answer some of the questions in the chat. But thank you, and we'll see you in about 15 minutes.